Hey everyone, and welcome back to the channel where we explore the incredible mysteries of our planet. Today, we're diving deep, not into the ocean, but right beneath one of America's most iconic volcanoes, Mount Hood. You might imagine a molten, bubbling cauldron of lava just waiting to erupt, right? Well, prepare for a mind-bending geological plot twist that's way more complex and fascinating than you could ever guess. When we think about volcanoes, the image of fiery, flowing magma is usually what comes to mind. But what if I told you that the magma feeding Mount Hood, that majestic snow-capped peak in Oregon, isn't actually a liquid river of superheated rock? Recent groundbreaking research has revealed something truly astonishing. The magma beneath Mount Hood is largely stored under near-solid conditions. Yes, you heard that right. It's more like a slushy, crystalline mush than a runny liquid. This isn't just a quirky geological fact. It fundamentally changes how we understand volcanic systems and how they prepare for eruption. For decades, our models of magma chambers often depicted vast reservoirs of molten rock. But now, thanks to advanced seismic imaging techniques and laboratory experiments that simulate extreme pressures and temperatures deep within the Earth, scientists are getting a much clearer picture. They're seeing evidence that the magma chamber under Mount Hood is actually a partially molten region, a solid matrix with pockets of melt interspersed throughout. Imagine a giant subterranean sponge where the sponge itself is solid rock, and the pores are filled with incredibly hot, viscous melt. It's a game changer. So, what does near solid actually mean in this context? It means that the vast majority, perhaps 50% to 70% or even more, of the material beneath Mount Hood is solid crystal. These crystals are incredibly hot, yes, but they're still solid. The remaining percentage is the actual molten rock, the stuff we typically call magma. This isn't just some cold, dead rock. It's a super hot, dynamic environment, but it's not flowing freely like water. Think of it more like a very stiff, super thick paste, or even a kind of geological concrete that's just starting to set. This high crystal content gives the entire system a much higher viscosity and makes it far less mobile than pure liquid magma. Now you might be wondering, if it's mostly solid, how does Mount Hood erupt? That's precisely the million-dollar question that geologists are furiously working to answer. The key seems to lie in specific triggers that can cause this near-solid mush to suddenly become more liquid and mobile. One theory is that new injections of hotter, more primitive magma from even deeper within the Earth can re-mobilize the existing mush. Think of it like adding hot water to a thick soup. It thins it out and makes it flow more easily. These new intrusions can heat the existing crystalline magma, causing some of those crystals to melt and significantly increasing the proportion of liquid melt within the chamber. Another crucial factor is the presence of volatiles, gases like water vapor and carbon dioxide dissolved within the magma. Under immense pressure deep underground, these gases remain dissolved. But as magma begins to rise and pressure decreases, these gases can exsolve or bubble out, just like opening a can of soda. These bubbles can dramatically decrease the density of the magma, making it more buoyant and helping it rise towards the surface. They also increase the internal pressure, which can fracture surrounding rock and create pathways for the magma to ascend. When you combine new magma injections with the exsolution of volatiles, you've got a recipe for rapid magma ascent and potentially an eruption. This slushy magma model has huge implications for how we monitor volcanoes and predict eruptions. If a magma chamber is primarily solid, then the traditional signs of an impending eruption, like rapid ground deformation or increased seismic activity caused by large volumes of molten rock moving, might look different. Scientists are now focusing on identifying the subtle signs that indicate a critical threshold is being reached, where enough of that solid mush is melting to become eruptible. This involves sophisticated monitoring using seismometers to detect tiny movements, GPS to measure ground uplift, and gas sensors to sniff out changes in volcanic gases. Think of it like this. A solid magma body is generally stable, but if new magma comes in and melts a significant portion, or if volatile gases start to bubble out rapidly, it can quickly transition from a stable state to an unstable, eruptible one. The challenge for volcanologists is to detect those transitions early enough to provide warnings to nearby communities. It's a bit like predicting when a delicate balance will finally tip over. The research on Mount Hood specifically uses a technique called seismic tomography, which is similar to a CAT scan for the Earth. By analyzing how seismic waves from earthquakes travel through the ground, scientists can map out variations in density and temperature beneath the volcano. They've observed areas where seismic waves slow down, indicating hotter, more molten rock, but these areas are often smaller and more dispersed than previously thought, supporting the idea of a crystal-rich mush rather than a vast, liquid lake. This understanding of near-solid magma is actually becoming a widely accepted paradigm for many volcanic systems around the world, not just Mount Hood. It helps explain why some volcanoes can remain dormant for long periods and then erupt explosively. The solid framework can act as a kind of structural dam, containing the melt until conditions are just right for a sudden release. It's a testament to how much we're still learning about our dynamic planet and how much more there is to discover. So, the next time you look at a majestic volcano like Mount Hood, remember that beneath its serene exterior lies a complex, partially solid, and incredibly dynamic system. It's not just a big, fiery pot. It's a deep, hot, crystalline puzzle that scientists are piecing together, one seismic wave and laboratory experiment at a time. This research isn't just academic. It's vital for understanding volcanic hazards and keeping communities safe. It's a powerful reminder that even the most seemingly stable features of our Earth are constantly evolving, and sometimes the most profound truths are hidden in plain sight, or rather deep beneath our feet. Thank you so much for joining me on this deep dive into the fascinating world of Mount Hood's near-solid magma. If you found this as intriguing as I did, please give this video a thumbs up, share it with your friends who love science, and don't forget to hit that subscribe button and ring the notification bell so you don't miss our next adventure into the wonders of Earth. See you next time.